Welcome back to the CS160 tutorial. In this brief video, we're going to take a look at how we might apply the programming process from the Gaddis textbook to our particular programming assignment. Well, here are the steps that we reviewed. This is the programming process from the Gaddis text. Now, I've divided these steps into two parts. One is displayed with white text, one is displayed with yellow text. The white text refers to those steps that actually have been done for us, and the yellow text refers to those steps that we're going to do. For example, let's just go through them. Number one, clearly define what the program is to do. We know that these are the requirements. The programming assignment contains those requirements, so clearly that's been done for us. We might need some clarification on those, but they've been written for us. Secondly, visualize the program running on the computer. We said that that was basically a description of the human interface requirements. And again, those are described as part of the programming assignment, typically in the functional requirements. Step 3 is use design tools to create a model of the program. Well, again, in this assignment and most of the early assignments in 160, that's done for you. Both the software architecture is defined in the assignment. It's one class with one method, the main method, and that main method has been described, its logic has been described by a high-level algorithm. We're going to assume that the instructor has checked that model for logical errors, and it is error-free. Although we are humble enough to admit that sometimes there are errors in our steps. Sometimes we leave some out, sometimes we get them in the wrong order, sometimes we misstate things. So it's also always good for you to double check our work. All right, let's focus on the steps there in yellow, 5 through 9. Well, we're going to be responsible for those steps. So we're going to be responsible for writing the code, correcting the syntax errors, running the code with test data, correcting any runtime errors we find that makes the program terminate abnormally or doesn't generate all the output we expect. And of course, what we're really after is making sure that the output our program generates matches the output that's in the sample runs of the programming assignment. I would note there that several of these steps are going to be repeated. Right? We mentioned that 5 and 6 are repeated, possibly for each line of code we enter, to make sure that we have no syntax errors. 5 through 8 might be repeated when our program terminates abnormally or doesn't generate all the output we expect. So we have to enter more code to correct that or revise the code that we've had already written. And then once we do get the program to terminate normally and generate all the output we expect, we want to validate that output. So we really have 5 through 9 is a large iterative process between entering the code and executing it and validating our results. Now, what we're going to do specifically for the tutorial assignment is we're going to repeat that large loop from steps 5 through 9 from the time we enter all the code and can run it to completion. And after we run it to completion, check to make sure we're getting the results that we expect. We're going to call that whole process there an iteration. And we're going to construct this program using 9 iterations. Well, what are we going to do with each iteration? Each iteration is going to address a small subset of requirements, usually implementing one or more steps of the algorithm. Well, why are we going to do that? Why not just sit down and implement all the steps of the algorithm at once? Well, because Programming is a really complex task, and it's easy to make errors, even when the steps seem to be trivial or straightforward, or I could do that in my sleep. It makes this complex programming task a lot more manageable since we can focus on a small step at a time and produce a small amount of code at a time. Since it's likely that at some time or another we're going to introduce an error, it makes it easier to find bugs. Because most of the time, the program errors we introduce are going to be associated with the most recent code we've written. Another good thing about dividing our implementation process into iterations is it allows us to achieve partial success early in the process. It gives us positive feedback. It tells us that we're making progress toward a solution. It's also good in that it evolves program functionality. Okay, by evolving program functionality at each iteration, we are addressing more and more of the functional requirements. So, with respect to, eventually you're going to be graded, right? With respect to the points you are earning, okay, you can achieve more and more partial credit that way. It'd be terrible if you worked on this programming assignment for 3 weeks and at the end of the 3 weeks you had nothing to show for it. That is, your program maybe still has syntax errors in it, or still won't execute to completion, or all the outputs that you have are incorrect. Okay, then you get minimal credit. This way also will maximize the amount of credit, partial credit, that you might expect. Now, some iterations will also decompose a more abstract step into a series of simpler steps. That is, not all steps of the algorithm are at the same level of detail. I mean, some mention Java constructs explicitly, and some, like step 11, mention a whole lot of things. That's written at a very high level that are going to result in lots of Java code to be written. So it makes sense to take those abstract steps, decompose them into a series of simpler steps, and we might have to decompose them more than once till we get to a level of comfort where it's obvious to us or straightforward to us to construct the Java code for that step of the algorithm. We call that process refinement. Another thing we're going to do is we're going to actually insert debug code to check intermediate results. One of the things that can really make it difficult for us to get the program correct is if we don't check to see that what we think we're reading in is what we're actually reading in. That is, if we read in values, especially numbers, and those are used in computation down the line, and then those computations are used to derive output. If our output's incorrect, we really don't know. Is it the computations that went wrong? Or did we read the values in wrong? So what we're going to do here is insert some debug code, number one, to check to see that we're getting the inputs incorrectly, and we're also going to do it to check intermediate results, like the computation of the daily interest rate. And then finally, with respect to validation, our validation will always be against the 2 sample runs. Because if we don't get those right, then we know our program incorrect. If we do get those right, then we have some level of confidence that the code we wrote satisfies the requirements of the assignment. Okay, now we are ready to enter into writing Java code and implementing our solution via iterations 1 through 9.